Welcome to Modern Math Online with Mr. Warner. Hopefully you're doing well and you're being healthy. So this is the notes that I was going to be handing out on Monday when you came to class. We'll still be going over the same notes. You're welcome to print those out if you'd like. If you don't have a printer, I have plenty because I printed them all here. I think you're allowed to come and pick up some like packets and things, just as long as you're not staying at the school. So if you need to get the notes, you're welcome to come and get it. Just email me first to make sure that I'm going to be here. Teachers are allowed to be doing their work at home, so please contact me if you ever need questions or anything like that. All right. Another thing about math space is some of the things is a little different, and I'll try and talk about that during the lesson. I'm going to try and have the lessons be less than 30 minutes, and then the homework, usually I'll try and see if you guys can get maybe 15 or less problems for your homework. Please make sure you get your homework done on time because just like we did before, if it's late, you lose points. So got to stay caught up. All right, so here we go. We've been talking about factoring quadratics. Now we're going to be focusing on graphing them. All right, so parabola is a shape of the graph of a quadratic equation. Okay. Oops, that's too thick. Okay, of a quadratic equation. Okay, it looks something like this. Or I guess we have an example down here. This would be a quadratic. It makes a parabola, and that's our shape that we're looking at. Okay. Again, the equation for a quadratic is y equals ax squared plus bx plus c. So everything we've been doing beforehand, we didn't have an equation. We just had an expression, a quadratic expression, which means we didn't have a y equals. All right? But now we actually have an equation, and we're going to learn how to graph those and what are the key features of a quadratic. Okay? So the first one is the y-intercept of a graph is the place where it crosses the y-axis. Okay, you've had this before when doing linear equations. It's still the same. It's always written as an ordered pair, 0, comma, whatever the y value is at that point. Okay, the x-intercepts, this has a parenthesis around s because sometimes there are no x-intercepts. Sometimes there's one x-intercept and sometimes there's two. Most of the time there'll be two. So x-intercepts of the graph are the places where it crosses the x-axis. Okay, usually there's two. So something like x, comma 0, and that could be our first one, and x2, comma 0. So these are just the 2 points where the parabola crosses. So for example, this would be, both of these would be x-intercepts. Okay. Oh yeah, and here would be our y-intercept. All right. Axis of symmetry. The axis of symmetry is a vertical line that cuts the parabola in half. Okay. For example, this right here would be our axis of symmetry. Okay, it just cuts that parabola right in half. Our parabolas are symmetric, and that's why it's called the axis of symmetry. So if you were to mirror or cross or fold that paper on that dotted line, then it would still be right on top of each other. Okay, this is written as an equation, x equals, and whatever that x value, so, and we'll do an example of that. Okay, the vertex is a point. Okay, it is either the highest or lowest point. Okay, it's also the turning point. Okay, and this is written as ordered pair x comma y. All right, and the vertex for here, this would be the vertex. Okay, it's the point where the slope on this side it's negative slope. Here it's a positive slope, and at the vertex the slope would be 0. So it's like right in the middle. It's always part of the axis of symmetry. Okay, maybe we'll write that there. On the axis of symmetry. All right, max or min value. Okay, it is the y value of the vertex. Okay, and that's just something like y. It's not an ordered pair, it's not an equation or anything, it's just a value. Okay, x value that maximizes or minimizes the function. Okay, so this is probably, just the wording I think is a little confusing, but the x value that maximizes or minimizes the function, so it's saying what is the x value that will give you the minimum. So here for this example, this would be the x value at 1 that gives you the minimum, which here would be -4. Okay, so anything else to say about that? Okay, the x value of the vertex. Okay, so that'd just be a value x. Okay, and direction of opening. So basically, if it's opening up, like this picture below, this would be opening up, or it will be opening down. Okay, and you just look at the graph. Okay, there are other ways to be able to figure it out just by looking at an equation, and we'll be covering that in the future. Okay, so this is basically what we're covering today, is being able to identify these key features. So given the following graph, identify the x-intercept. So here the x-intercepts, well, there'd be 2 of them because it crosses the x-axis twice. One would be right here would be -1, 0 and 3, 0. Y-intercept here would be 0, -3. Okay, and just a reminder, it's always x, y when you're doing your ordered pairs. So here would say x would be 0 and then would go down to -3. Axis of symmetry would be that cuts the parabola equally in 2 parts. So that would be x equals 1. Again, it's always x equals, it's an equation. It's a line, vertical line. The vertex here would be x would be 1 and y would be -4. Is the vertex a max or a minimum? So we'd look at this and say, well, this is the smallest value, so it would be a minimum. And what is its value? It'd be -4. X value that maximizes or minimizes the function. Again, that's just the x value of the vertex, so -1. And direction of opening would be up. Okay? So just a couple things. When you do it on math space, some of the wording is just a little bit different, okay? So rather than saying a maximum or a minimum, they say an absolute maximum or absolute minimum, okay? And rather than having them write down for the y-intercept and x-intercept, they say something like, what is the y value that's in the y-intercept, or something like that. So you'd only need to write down what is that y value, or what is that x value that's for the x-intercept, okay? Make sure you read the instructions very carefully when you do the math space, because sometimes the wording is a little different than the way I teach, okay? So just make sure you read that. Also, on the right side of your homework, there is also hints, and sometimes there's even videos that will teach you how to do the stuff if I didn't do it very well, okay? And then you're also welcome to just like Google online, like if you're confused about maybe the axis of symmetry, you could Google axis of symmetry. I'd probably want to include the word quadratic for any of these if you're trying to learn more about them. Okay? All right, so I'll try another, and then I'd like you to try one. Okay? So here we have our x-intercepts. We have two. One's here, one's here. So we'd have -2, 0, and 4, 0. Y-intercept would be over here. It'd be 0, -8. Again, it's x, y. Axis of symmetry here looks like it's about the same as what we did on our last problem. X equals -1. Hopefully it's not the same problem. No, it's not. Good. Okay, and then the vertex would be right here. My guess is this is probably -9. So we'll do 1, -9. Is the vertex a maximum or a minimum? It is a minimum. And what's its value? It'd be -9. X value that maximizes or minimizes the function. So again, that's just the x value for our vertex would be 1. And the direction of opening would be up. Okay, so give this a try. Pause if you would, and give this a try before you go any further. All right, so hopefully you got this. X-intercepts, we have 2. One is at 0, 0, and the other is -2, 0. We have our y-intercept is also 0, 0. Axis of symmetry, it looks like it's x equals -1. Vertex would be -1, 2. The vertex is a max, and its value would be 2. The value that gives you that maximum, the x value, would be -1. So again, these are just the parts of the vertex. And then direction of opening in this homework problem, it is down. Okay, so that's half of what we covered today. The rest is modeling quadratics. Okay, so quadratics are very useful in many world life situations. For example, throwing a ball. Okay, when you throw something, it always follows a parabola. Okay, like throwing a ball, a missile, or an arrow, or throwing a stone, or something like that. There can also be like profits of sales, or they use lenses and curved mirrors a lot to use parabolas, like, for example, a dish, a TV dish, or something like that. Okay, so we're going to go over some examples of when you would maybe want to, like if I give you like a word problem, you'd need to say, well, what are they actually asking for? Is it going to be the y-intercept? Is it going to be the x-intercept, or part of the vertex? Okay, so for a problem when they're like saying, what is the starting point, or at what height does the rocket start, or at what height is the rock thrown? So something that has to do with initial time when it begins. Okay, so if we had like a little graph of this, and we threw a parabola, okay, this right here, this would be the y-intercept, 0, y. Okay, oftentimes in word problems, the x value is time. So if time equals 0, the height would be y, okay? X-intercepts, okay? I mean, most real-life situations of parabolas are like this. You could also have others that are not, but I'll probably do most of the examples like this. Or, I don't know, let's do one upside down, just to do that for the heck of it, okay? So here, x-intercepts, we have 2, okay? This would be x comma 0, this would be x comma 0, but a different x, this would be like x2, and this would be x1, okay? So some of the wordings for that would be, what time will the ball bounce on the ground? Or at what time will the arrow hit the ground? So the thing about, we talked about x is typically time, okay? Time never starts negative time. So time always starts at 0. So usually we'll never use the x-intercept that is when it's on the left side of the y-axis, if that makes sense, okay? Time always starts at 0 and goes forward, okay? At what time will the arrow hit the ground? After how many seconds does the rock hit the lake? Okay, so here this is where that would happen, okay? Often, like I said, oftentimes parabolas are going to be like this, where you maybe threw a ball and it hit the ground, something like that, and that would be your x-intercept, okay? All right, other questions that could be something like, after how many seconds does the rock reach its maximum height? Or how long does it take to reach the maximum height? So here, let's do another example. We could have a parabola, something like this. That's not very good. But let me change that a little bit. Okay. Something like that. Okay, so this would be the starting time. Okay, and then the axis of symmetry would be there. This would be the vertex. Okay, but all they're asking for here, at what time does it reach its maximum height? Well, time is always our x, okay? So it would just be the x value of the vertex, which is written right here, okay? And then other questions like, what is the maximum height that the arrow reaches? Or what is the height when it explodes? Or what is the ball's maximum height? So same sort of thing, you would have the same sort of, I want to change that, something like this, okay, where this would be our axis of symmetry, and this would be the y value, because that would give us the height, and this with there is the time, okay? Okay, so let's do some examples, and I think we're good. Okay, so for these ones, we're not trying to solve for anything. We're just supposed to identify what is the key feature that they're asking for. So a baseball is being thrown from the top of a hill to a friend at the bottom of the hill. Sketch the graph. So just an example of what could be. He's on a hill, so he throws the ball to his friend. Something like that. Okay. And identify the parts of the graph this question is looking for. Okay, so for A it says, what is the starting height of the baseball? So that would be like here. And what is that? Well, that is the y-intercept. Okay, when will the ball reach its maximum height? So when, that would be time. Okay, so that would be the x value of the vertex. Okay, and what is the maximum height that the ball will reach? Well, that would be our y value for our vertex. Okay, and when will the ball hit the ground? Okay, so that would be here at an x value, would be the x-intercept. Okay. All right, so basically you're going to do this again. I'd like you to pause and see if you can do this one. draw a little sketch of what's going on. Zach kicks the ball into the air towards Katie. Sketch the graph and identify the part of the graph each question is looking for. Okay, so pause and give that a try. All right, so Zach kicks the ball to Katie. Something like that, I don't know. Okay, when will the ball reach its maximum height? Okay, so when, would that be a time? Okay, so this would be the x of the vertex. When will the ball hit the ground? This would be the x-intercept. What is the maximum height the ball will reach? Okay, this is our y of our vertex, y value of vertex. And what is the starting height of the soccer ball? Okay, and that would be your y-intercept. Okay. Okay, and let's just do one more. Dax is walking tightrope 30 feet above the air. So it's going to be something like this. Okay, and this is maybe the ground. This will be our y, and this will be our x. Okay. There is some slack in the rope. Sketch the graph and identify the part of the graph each question is looking for. Okay, so here maybe he's walking on this tightrope. He has one little bar so he can balance. Okay, what is the starting height? All right, well that would be your y-intercept. When will it reach its minimum height? When is a time, so that would be the x value of the vertex. And what is the minimum height? Well, that would be the y value of the vertex. Okay. All right, well, if you have any questions, let me know. Again, the homework is not going to be as long as the homework that we did when we were actually in class. I think you get a couple tries on the homework. You lose a little bit of points every time you get it wrong. And if you absolutely don't get it right, then you just lose the points. Just like we did in class, you're going to get participation. So if you attempt every problem, do your best. Don't just put in answers and want to get half the points. Do your best to try and get the problems right. I'll put those in on the due date. If it's late, you're going to lose points. So make sure you stay caught up. Watch the video before you do the homework. Ask questions if you have any. Send me an email. Again, you're welcome to Google and see if you can figure out how to do the problem. I figure you actually probably learn better if you try and figure it out by yourself. But if you can't figure it out, please let me know. And again, stay in contact with me. I'll probably be sending you emails here and there. Okay? All right, we'll see ya.